Thanks, Carol. Hello everyone. My name is Eric van Buggenhout. You might have seen me before or heard me before. I teach quite a bit for SANS, especially this year, given the new SEC 599 course. Who am I? Just a quick word on that before we get started. I'm one of the course authors of 599, which is a new course that we have up and running within SANS, which is focused on defeating advanced adversaries. Now, a bit of an idea on why we developed it and what we're trying to achieve in the course. Because one of the topics that we focus on is, for example, threat hunting, how to do security monitoring in an effective way, is because we noticed that a lot of the blue and red teams are often not really aligned to each other, so they don't always talk to each other. So it's one of the big things that we discuss is how to do that well, how you can get most value out of that. So we have a bit of we like to call it purple team approach in the course. One of the fundamental things that we discuss is how to get visibility in your environment, because of course there's real-time monitoring, there's security monitoring you can do 24/7, IDS alerting, all of that stuff. Typically looking for known bats, if you will. That's an effective approach, and you need part of that, of course. It's definitely not bad, but you need a bit more. And that's when we start discussing things like threat hunting, where we go for an approach where we try to routinely collect data, where we try to get information about our endpoints, about our systems, to understand what are anomalies, if you will, but also just reasons for suspicion, things that we want to further investigate. A tool of choice there is, of course, OSQuery, which is rather impressive and very, very impressive toolkit developed by Facebook initially, which is now more and more being used. So this is the topic of today's webcast. We're going to zoom in on OSQuery. We're going to look at Kolide, which is a centralized management endpoint, if you will, or a centralized point from which you can query your OSQuery installs, or you can query your OSQuery installs. I always find it funny when I pronounce it. But how you can centrally manage that, how you can define query packs, and how you can start using that, for example, in Elasticstack to get visibility. So that's a bit the topic for today. Also, a very quick note, my apologies for last week's reschedule. I've been teaching quite a bit and my voice wasn't up to standard. So that's the reason why we're doing this today. So that being said, let's start off and let's start looking into this. What do we want to do today? We're first going to have a chat on what OSQuery is, how does it work, what are a bit the internals, just a small introduction to make sure everyone knows what we're talking about. Then we'll zoom in on Kolide. So the enterprise-grade OSQuery, how it works, what you can do with it. So Kolide is being developed and being pushed by a commercial firm, which is called Kolide. So they have Kolide Fleet, but the software itself remains still free to use. So it's pretty effective, and we're going to look into how it works and how you can set it up. Then we're going to discuss some related projects, some interesting insights, some initiatives that are ongoing, because this community at the moment is very active. There's a lot of stuff that's being built, which I admire, because a lot of the things I think are highly effective. And if we use it right, we can get some amazing visibility without necessarily have to breaking the bank to getting all kinds of commercial solutions in place. While I have no issue at all with commercial solutions, I'm a consultant myself. I do think that quite often a lot of value can already be achieved by being smart, by using the right technology, and by getting a baseline visibility or a detection capability already. And that's the thing that we want to discuss today. We'll also do a demo where we play around with a Kolide environment that we have up and running, where we look at the Elasticstack, how we can use that to start getting some query pack definitions, and how we can start using it throughout the enterprise. Of course, there will be time for Q&A as well. So we estimate that our content-driven part, which includes, of course, the theory and the demo, will take us about 45 minutes, after which you will still have 5 to 15 minutes time for Q&A, after which you can, of course, get back to your day or to your evening, depends a bit on where you are. So let's get started. What is OSQuery? If you have any questions, of course, feel free to type them in the questions window, and we will, of course, then address them during the Q&A. Thanks. So what's OSQuery? By Facebook allows you to easily ask questions about your Linux, Windows, Mac OS infrastructure. What's the whole goal? Well, it has different use cases. It's not only about security monitoring. Quite some environments also use it for compliance monitoring or compliance assessment to see, to verify configuration, to ensure that systems are configured as they would be expected to be configured. So it can be used to review, to assess the configuration of end systems. Could be workstations, could be servers. The whole idea here is to try analyzing, to getting data, to collecting data, but it wants to provide a generic interface to analysts. So the whole goal is, for example, to make sure that if you are, let's say you're not familiar with Linux, you have never used it, but you do know, you're familiar with threats, and you would want to analyze, for example, what users are configured on your infrastructure, being that Windows or Linux machines or anything else. The goal would be to have, and that's what OSQuery tries to do, is make sure that you have one language that you can use, which is SQL. So it's built on SQL, it uses SQL language to be able to query that infrastructure. You could say, if you are a Linux user, you would know, okay, if you want to know what users are configured, you could, for example, do cat @cpasswd. You know what users are configured locally on that machine. If you're on a Windows machine, you would probably run something like net users. This is where OSQuery comes in, and what it allows you to do is just select star from users, and it will give you visibility on what users are configured regardless of the OS. So it kind of makes the translation, it does it for you. So you don't really need to know how you need to run a certain command. You just need to know the query in OSQuery, and OSQuery will take off the rest of it, which is pretty impressive. It supports ad hoc queries, meaning you can just run a query quickly across your fleet to get visibility on what's happening inside your environment. But you can also schedule queries, which then run on a periodic basis, which can provide value if you want to know, for example, how your baseline looks like. So what's going on, what's changing. For example, collecting all of the running services or all of the services configured on your Windows endpoints on a weekly basis. That's very easy to do in OSQuery. So you can build query packs, if you will, that run periodically. So you can start using it for threat hunting, to find anomalies, to find suspicious behavior, and so on and so on and so on. There's also add-on solutions which are being developed on top of OSQuery. I'll discuss them in a second. But know that OSQuery, the basis is already very powerful, but there are initiatives and plugins which are being built on top of it. So just to give you an idea, and I'm immediately jumping into a couple of details here and a couple of examples. Imagine the query that you see on top in the image here in this slide. Select UID name from listening ports L processes P, where L.PUID equals P.PUID. So what are we trying to achieve here? We are looking for processes which are currently listening on a certain network port. That's the whole idea. It's a pretty straightforward query, but it shows how you can get creative with queries and how you can keep on changing things, enriching queries, and so on. So here, for example, this is a very nice example, which is often used when describing how OSQuery can be useful for security monitoring reasons or threat hunting. Select star from processes where on disk equals 0. This will detect running processes that do not have an executable stored on disk. So that could be an interesting one to run across your fleet. If you're looking, for example, of certain variants of files, malware, you want to get some visibility on that. An interesting one here at the bottom, and I didn't author it myself. This one was developed by a person who's actually looking into creating an OSQuery mapping on the attack framework. More on that later. But where you're looking, for example, for an SVC host.exe process that doesn't have services.exe as a parent process, which would be weird, which would be something you would want to investigate, because most likely that's not an actual SVC host.exe process. It's probably masquerading something else. So that would be something that you would want to look into. The latest version of OSQuery has about 226 tables. So I'm just going to bring up the schema here for a second. So bear with me. So this should be the OSQuery schema that you can see now. What do we see here? This is the latest version of the schema, so it does change. It's very much, it's an active development. It's quite active development that they're doing on top of it, and I'm scoring very quickly now, but I do it on purpose to show you how many different tables there are. The list is pretty impressive. It's pretty crazy how quick this is going as well. So there are 226 tables as of version 3.30. Example tables include, for example, here users. If you go into that one, let me just grab it. Here you go. This is the users table to get local user accounts. So you see user ID, group ID. You see the username. You can get the actual description of what tables look like. So very good to reference this. I always advise my customers and people who are using OSQuery to just use the online source because it changes rapidly. There's a lot of stuff that gets added. So this is a very good reference to use, which is online available. Do note that there's also an indication of those tables on which OSs they are present, so for which OSs they are relevant. As you can see, the users table is available for Mac OS, for Linux, for Windows, and for BSD-based systems, as you can see on the icons here. So it's a pretty broad, pretty generic table, which can be used in different OSs. That's one, but there's more. There's, for example, a Yara one, which is pretty interesting. So you can even look for Yara matches. So if you're using Yara rules, you could start looking for files which match even your Yara rules. So this gets very interesting. It's very broad. Other ones that I would like to highlight, just Windows events, for example. Of course, this is an you guessed it, a Windows only, because it's looking at Windows event IDs, which you could then select. So pretty nice. On the processes part, there are a whole bunch of different queries, but you can see here, for example, tables. My bad. So you can see here, for example, the structure of the processes table, and you can see how big that one is. You can see the on disk one here that I just mentioned, with process path exist, yes is 1, no is 0, unknown is -1. You probably want to look into the 0 and -1s here, right? So that gives you a bit of an interesting overview. To keep track of that, again, use the online references. This is freely available. It's a good one to know as well, but also to get creative, because a lot of the value comes when you start combining these queries further, because the baseline queries are good, but quite often there's more that you can achieve. So let's get back to our slide deck. Sorry, my bad. So latest version of OSQuery has 226 tables. Quite a lot of that is available online. So just putting this a bit in perspective, OSQuery versus EDR tools versus Sysmon, and so on and so on and so on. Just putting it all together, so EDR tools are mostly focused on detection and prevention of activities in real time, meaning if there's process execution of, let's say that Word suddenly launches a cmd.exe because potentially someone put a small macro in there, so it launches an executable. That would be something that you would want to look into, you want to analyze, you want to further look into. That's real-time prevention detection. That's where most of the EDR tools really show their value, because that's what they're good at. They also usually have a form of hunting capabilities, for example, Yara rule scanning, but they're also available. They can do responsive actions as well. That's an EDR tool, endpoint detection response. OSQuery does not offer a responsive capability just yet, so that's not what it's doing. It's all about data collection, all about detection of getting that insight. For threat hunting, that's where OSQuery probably is even more capable, because it can do that routine data collection, as we will see. But just know that OSQuery is not a full alternative for an EDR tool, and an EDR tool is not a full alternative for OSQuery. They are distinct technologies which are not mutually exclusive, but it depends on your environment, on what you're looking for, or what you're hoping to achieve. Then, for example, Sysmon, which is very well known as well, and a great tool. I use it all the time. But again, here, this one is also focused on generating real-time logs and events to provide insights in what's happening on a system. Example given here, the one that I always use when I talk about Sysmon, is trying to use, for example, event ID 10, which is process access. Could be used when you focus on the lcells.exe process to look for lcells injection, which is very common when we're looking into Mimikatz style attacks where adversaries are trying to dump credentials from memory. So that would be straightforward to spot with Sysmon. But again, OSQuery has a different goal. So they're looking at different things. What OSQuery tries to do is focus on periodic data collection to review the configuration of systems. Think persistence, for example. Persistence is a good example of something that would be harder to spot with some of the EDRs and tools and Sysmon, because it's not real time. It's about, oh, someone added a scheduled task on that system. It's a scheduled task that only exists on one machine across my 1,000 endpoints. So I might want to have a look into it. So that's where OSQuery excels. Gives you a bit of a structure and understand what they're all about. So how could you use it in the enterprise? Well, two ways. It can run standalone, literally as a portable executable almost, where you can just have the executable running to get some data collection, or you could install it as a service to do periodic collection. Now, to give you an idea of why both of these could be useful, we use it standalone in some of our forensic investigations when we want to quickly get visibility on what's happening on a certain endpoint, because we don't really want to push software to it because of many reasons, because it's a bit more overhead. So what we've developed just internally as an FYI at my company, which is Enviso, which is a Belgian cybersecurity firm, one of the things that we do is we've developed a package which uses OSQuery as part of it, just to do some initial data collection of a system. So it gets Windows event logs. It runs a whole bunch of OSQuery queries just to get visibility on what's happening on that endpoint, what's available. Are there any suspicious scheduled tasks? What's running there? So it does select start from processes, for example. But it's standalone. We don't install it because the idea is during an incident, we just want to get some quick visibility on what's running on those machines. When you're not running in incident mode, you could deploy it as a service across the entire enterprise. And then you also get a bit more access. So some of the tables in OSQuery, they will want you to install it as a service. So you can get what they call an evented table. So you can get more information, more visibility. We'll discuss that a bit more once we go into specific queries. But know that if you install OSQuery as a service, you get more of the capabilities. And of course, you can also start then, for example, using Kolide to centrally manage it. But the two have a different use case. The two approaches are perfectly valid for an enterprise environment. I've seen both of them being used. So what supported OSs are there for OSQuery, or what OSs.OSQuery support? Well, most of the major families are supported out of the box. For example, you've got your Mac OS, CentOS, Linux, BSD, Windows. All of that is supported out of the box usually. One interesting note, though, is that it was originally not developed for Windows. So the Windows variant is actually a port is a bit unrespectful, but you'll see that quite some of the capabilities, for example, the ARA stuff, everything linked to file integrity monitoring, that's usually not available on Windows, but it's more and more being built into it by third-party plugins. So there's a whole bunch of organizations and initiatives which are trying to bridge that gap. Although I also think now I'm not in that close contact with the OSQuery developers, but I would guess given the current focus on it and it's gaining a lot of traction, I would imagine that a lot of the capabilities will start being built into the standard Windows version of OSQuery as well. It would just make a lot of sense. But there's already a few plugins available, which, for example, try to replicate the file integrity monitoring of OSQuery Linux and Mac OS on Windows. One of them is, for example, Polylogics, which we'll discuss a bit later, a commercial firm, but they're developing a plugin that you can use on top of OSQuery. It's still in beta mode, so it's not in production yet, but I've played around with it a bit. It's pretty interesting. So let's start looking into Kolide then, right? Because that's all OSQuery. So running OSQuery on your machines. Now, how do you centrally manage it, and how can you get it up and running? So first of all, Kolide Fleet is an open source OSQuery manager. So the idea is that OSQuery gets deployed across the enterprise as a service. So you have it running on your Mac OS systems, on your Linux machines, on your Windows machines, and you have a central engine that you can use to do monitoring upon. So you use one central stack. That is the central place where you define your query packs, where you define what you want to collect, where you also schedule how many times you want to run those queries. You can also adapt, for example, how you want to do your data collection. So it uses TLS, HTTPS TLS, just as a standard communication channel between the central server and all of the endpoints. But what's also interesting is that you can define how data needs to be collected. And what does that mean? You can define, for example, that you want to have queries which are differential. So that means they will also only send you the differences. So if, for example, you do a differential select start from services, you will only get the services which have been added or changed since your last run of the query, which is interesting. So you can actually use that to do anomaly detection, if you will, or to just get changes in your environment. You could also opt to just routinely collect everything every single time. What we do, for example, in some environments is we select data periodically, so every week, but we just select everything and we do all of the baselining, the analysis in a central Elastic stack, which is another way of doing it. Both of the approaches have value. It all depends on your environment, what you're looking into, but quite easy, quite straightforward to manage that in your Kolide fleet. So looking at an example stack, if we consider that we want to stick with our free stuff, I'll put it that way, would be using OSQuery on the endpoints, using HTTPS polling and logs being forwarded over HTTPS towards that Kolide fleet, where you can do your query management. And then, of course, you could forward logs from there using, for example, FileBeat to an Elastic stack, which is pretty nice, pretty interesting setup. I've built that in a couple of environments. It scales pretty well, pretty nice to do, and it is enterprise grade. That way you can actually manage it centrally. Some projects, right? We're going to look into Kolide in just a second, but let's start looking at some related projects on this, because how do you develop queries? Well, one idea would be to say, I'll just start writing my own queries. It's not a bad move, it's not a bad idea, but that will require, of course, some expertise. You will need some people who know how this is done, how you can write them, people who know the environment. But a lot of stuff is already happening. This community is very much alive, so people are writing stuff in quite an impressive speed. Just a quick one, but this is, of course, one of the basic elements that we more and more see being used for detection capabilities to explain how does detection work and what can you detect. It's the MyToAttack Framework. It gives you a proper overview of adversary techniques. It's quite big, quite a lot of information available. What's the whole idea of MyToAttack? It's to discuss what are the adversaries using. So what are their different tactics? That's the line in blue. That's all of them are tactics. This is the specific one for Windows. But then all of the ones at the bottom, there are techniques. So for example, you've got code signing there under defense evasion. Bypassing UAC is a privilege escalation technique, as you can imagine. But the whole idea is you can open those up and you can get visibility on, one, who uses that technique. So what adversary group, what is the technique all about? But it also tells you how you can potentially try to prevent it and how you can detect it. And that gets pretty interesting from our perspective. This is more and more used as a standard framework. So the attack framework is rather impressive. It's by Mitra. You can find it, of course, online. So I'm just swapping screens here again for a second. You have this entire overview here of the Mitra attack. It is pretty impressive. So you can, for example, here go into bypass user account control, and you'll see that you get an entire description of what it's all about, how you can do it, and who's using it, how to mitigate it, how to detect it. Very nice. So this is an interesting platform. Now, why do I mention it here? Because we can use this. We can use this to start generating a detective capability. So let's get back to the slides. Here's another example, DLL search order hijacking, another one of these. Lots of these techniques are nicely described and a lot of details have been added in the MyToAttack framework. So here's, for example, a very interesting project again, developed by Theo Seller. It's a GitHub page, if you will, the GitHub account. They've started creating OSQuery queries that have been mapped to the attack framework. Now, this is pretty interesting. It's not perfect, of course not, because it's a work in progress. It's community driven, so there's no enterprise behind it. But the whole idea is to map OSQuery queries that can be used to detect certain parts of the attack framework, so detect certain techniques. So let's open this one up. So if you look at the GitHub page, you have quite a few different queries available. You can see, for example, network connection listening. So this is typically for processes that have that are listening on a certain network port. If you would look for your traditional backdoors. And now the one that I stole and I just used as an example because I do like it is the one about the parent processes. So you can see here a very nice reference. But you can see here the queries that have been written, how they've been created, and you can see here the reference, of course, towards the actual attack technique. In this case, for example, detect processes masquerading as legitimate Windows processes, which is attack T1204. If you go back to your attack framework, you can see here T1088. Those are actual techniques. But so you can already imagine getting these rules in place, getting these scheduled, will provide some interesting visibility. If you periodically collect this kind of information on your endpoints, you'll be able to see quite some impressive stuff. And you might see, for example, in this case, the first one, I actually use the second one as an example, but here again, we see that there's a query which is, I'll just highlight it here. There's a query which is looking for services.exe which don't have a parent process of winInit.exe. Right? So this is very standard. If you have a Windows-based environment, you'll know that the services.exe process always has winInit.exe as the parent process. If it doesn't, that means something weird is happening and you do want to know about it. So you want to investigate, you want to see what's happening, and you want to look into it. Same thing here for select PIT from so the process ID from process where name is service.exe and svc host.exe. So it's got a whole bunch of these different ones to look for interesting processes. You can see here variations, for example, PowerShell.exe from Explorer.exe and all kinds of links. You can, of course, customize this further and adapt it to your environment, but it's pretty nice to see that all of these projects are coming together and we're getting some interesting visibility and a standard structured way of doing this, of exchanging this kind of information and queries that we can use on top of OSQuery. Another player who is very active in this is Palantir, which is a commercial company, but they are working on a lot of queries that they are developing for OSQuery, which can be used to get stuff done. So Polylogics then, this is the query, the plugin that I already mentioned. I do mention them because they still have their plugin for free. It's available. You can get it. It's still in beta mode though, so they're trying to bridge that gap between the Windows deployments or the Windows implementation of OSQuery by adding file integrity monitoring, process auditing, model-specific register details, and removable media events. Those are the 4 big things that they're building in. The biggest, for me, the 2 biggest ones here, which I like to look into a lot, is file integrity monitoring and process auditing. Because if you look at the extension, the things that it provides or the use cases which it enables, for example, an embedded Yara engine to scan files with Yara rules. I do love this one. It's a very nice one. For example, what we do in the course during one of the labs is we develop a query which is going to monitor the downloads folder, and the moment that there's a file that gets written on in the downloads folder or in, for example, a user-controlled folder, it's going to immediately run the Yara engine to look for known matches and to look for hits on your Yara rules, which is pretty impressive because you could use that to then immediately respond to suspicious behavior, to known bats which are being written in your environment, or to just standard files which hit on any of your Yara rules. So this is Polylogics. Again, these guys also have a website available, so they have an extension here that you can get. So they are actively developing on that. So there's a lot of stuff that's being done at the moment. So pretty impressive stuff. So this is one of those plugins that I mentioned, which tries to bridge the gap between Mac OS, between Linux and Windows OSQuery, because the Windows one, of course, as I mentioned before, is a bit more limited as to what it can do. So writing your own stuff. So let's zoom in on this. A couple of examples. We're going to use these during the demo as well, but just a couple of things to take into account. Select star from processes. This is an interesting query, as you can see, because it's going to return process information. The query, however, has a few limitations. For example, it does not return the process username. It only returns the user ID of the process, which makes sense, right? Because you don't want to replicate data. This is let's put ourselves in a SQL mindset, in a database mindset. You don't want to have the username field both in the process table and in the user table. That doesn't make sense. So it only has the user ID. Does not return the parent process name either. It just returns the parent process ID, which is nice, but you might want to get some more visibility. So here's a simple fix. Note that I put simple between double quotes, because if you know about SQL and if you use it and if you know how to write SQL queries, this will indeed look quite simple. If it's new to you, if you've never used it before, this might be a bit more straightforward, a bit less straightforward. So take, for example, here, I'm doing a select p.star, h.star, username, u.type as user type, and then pp.name as parent name, pp.cmd line as parent cmd line. What am I doing here? I'm creating a set of joins. I'm selecting the processes table, which I'm joining to the users table. Then I'm joining again with processes to get the parent process name, of course, and I'm also joining it with the hash table. Very nice. So what does this thing do? It gets all of the running processes. It adds the parent process name to the overview. It adds the process user name, so not only the process user ID, but then also it adds the hash of the image that's on disk. So the executable that is on disk, it also adds the hash of that one. So you could also look for known bats, for example. Now, you could say, Eric, that looks crazily complex, but the big idea here, of course, is to is to spend a lot of time developing these queries, because you can create them, you have the time, you can get creative, you can build up your expertise, and then you write them once, but you execute them continuously. You execute them periodically to get visibility about what's happening in the environment, so you can get some pretty impressive visibility on the cheap, if you will, without having to, again, go for any kinds of crazy commercial tools, but you get that visibility. And because you can just use SQL and you can create joins between different kinds of tables, you actually get some very impressive visibility. So this is one of my favorite things to do, is to look into, okay, but how can we enrich existing queries? How can we get more data, and how can we add more stuff on top of this? So let's look into a demo for a second. Let's start zooming a bit on that. Let me just go back. I'm just going to use our online lab environment here. It actually went into a safe state because I spent a bit too much time talking. It's a common issue. So it's just resuming. There we go. Now you might notice that this environment lags a little bit. This is because this is the online environment that we use. Do note that this is the lab environment we use in the class as well. So I'm just using it to demo a couple of the capabilities here. Now, what do I have available here? I have a central Kolide stack here. I've got Kibana running here. So there's an Elastic stack, which is running. It currently doesn't have anything in there, as you can see. And I've got an Evo web server here, which is hosting some payloads and some stuff. So this is an interesting area to play around a bit. So let me just connect to my central Kolide stack. There we go. So you can see I have one specific host online. I hope in your enterprise environment this will look a bit bigger. But you can see I'm running a bit of an older version of OSQuery. I should update it. Actually, it's a 2.11. The latest one is 3.3. But that doesn't affect me too much. It just means that I don't have all of the different capabilities which are available. I did install the Polylogics plugin, so that gives me some pretty interesting visibility. So a couple of things I can do. I can, of course, look into these hosts and I can start playing around with some queries. For example, I could say, hey, I would like to create some new queries. Let's build one. So I would say I want to collect, for example, process information, and I could go select star from processes. It does this autocomplete thingy, as you can see during the while you are typing your queries, which is nice. It's pretty useful. Although note that if you have like third-party plugins, like for example the Polylogics ones, they create their own tables. Those are typically not included in here. Why are they not included? Well, because they're not part of the stack or the standard OSQuery tables, so you don't see them here. You can also see the different tables which are available here as well. So you can get their context. You can get the different the structure of those tables, so you know how to write your queries. I do advise when you're writing queries to just have what I always do. I just open up the OSQuery schema, the online one, and I use that one as a support and to start doing stuff, because that's just an easy way of doing things. Of course, I do need to select a bunch of hosts, so I'll just run this on all hosts. You can see, of course, you can add labels here. You can do this on specific groups, on specific types of systems. So I'll just run this one on MS Windows, and we should see this coming back. Right? Murphy's Law, right? Now everything breaks. So there we go. I get some visibility. I'll just open this a bit because it's a bit bigger. But you can see I have the host name there. I have the command line, right? CMD line, so how that was launched, which is nice. So I can get that visibility. And if you go further to the right here, you can see that there is, for example, it's a pretty long one. The current working directory, the name of certain processes. You can also see the user IDs, and you can see the on disk, all of the different fields. As you notice, however, for example, what I mentioned about the parent process name, that one's not there. There's only the parent process ID, which is PPID. Where is it? Or is it parent ID? I should check. I don't know the field name by heart, so my bad. But this is a very big one. I know why that is, because I'm running a couple of dirty things on here, which will allow me to discover things. Here it is. So this is the parent. That's actually the parent ID. It's the ID of the parent process, which is good, but it's a bit annoying because it doesn't give me full-blown. Well, I would still need to look up what parent, what process 440 is, right? What is it actually? I can guess, or I can try looking into it, but you probably want to get that as part of your query. Same thing here. So you have a UID, so a user ID, but you don't have a username, which is kind of annoying because you don't have that visibility. So I'm going to cheat here, and I'm just using a couple of my processes here, or a couple of my different queries. Let me just grab the one that I just discussed during the demo. So my bad, I'm just going to go back very shortly here. So I'm just going to use this query. It's a pretty big one. I'm not going to try reconstructing it here live, because that's going to take me a bit of time and might also lead to me making a couple of mistakes. So let's not take the risk. So I can just paste that one in here. I'm just putting it in Notepad first because I don't want to mess up my copy paste. This is our online environment. Want to make sure everything runs well. So you can see it's a pretty logical query, if you will, especially if you're a bit familiar with SQL. It looks intimidating, but it's actually pretty straightforward. It's not too crazy. So I'm just going to copy that one over here. I'm going to again go back to my normal window, and then I can do that select. You can see the p.star, h.star username. So I'm getting a lot of information to get visibility. And this is all built in OSQuery. There's no plugins that I'm using here, nothing third party. It's all standard OSQuery. So I can run that again, and you will see that he starts running again. OSQuery is doing its bidding now. It's of course fetching the results of the query. There you can see it. You can see it doesn't have any crazy performance impact, right? It's not too bad. You still have the hostname, CMD line, so all the stuff that we knew already. Now these fields are organized in an alphabetic way here. But you can already see here, for example, okay, there's the name MD5, for example, that's already one. It's an effect of the hash, right? I selected all the hashes. So I have MD5, but I'll also have the SHA-1 hash. So you could almost immediately, for example, know, oh, look, in that version of Windows 10, that should be the hash of winlogon.exe. So it would be something you can immediately try to analyze. It's just an example, but you can see that you get that visibility immediately. There's parent, but look, I've added something else. I've also added parent CMD line. Very nice. So you can also get the parent command line. You can get the parent name and the parent command line. So it's an enrichment that you're doing here. And here, as you go further to the right, you can see the SHA hashes of the executable. But you can also see here, for example, UID, and there you have it, username. So you can see the user type as well. So special. It's OSQuery language, if you will. Why they call it special, but you can see as what those are running. So you can see network service system nick.fury, which is my local roaming is domain account, by the way. But so nick.fury is the user that I'm using here, and you can get that visibility on here. So that's pretty interesting, gives you some visibility. That's just one of them. There's a few others that you can start running. So you can look into, for example, this guy, select start from processes where PYD, and then looking for that mapping on the parent processes to see if you see any processes which look like they are Windows, well, standard Windows processes, but which are not. So let me just run this one. Again, I use this one straight from the GitHub page that was created. So as you can see, pretty straightforward. Nothing found here because I'm not doing anything strange here. So let me just try something to see if I can get an interesting results here. I have an executable here which is called svc host.exe, which doesn't make any sense at all if I would run that. It's just a small payload. So let me just run that thing. See what happens. I think it's running. Fingers crossed. There you go. Look, there's an interesting process here. It is command line explorer.exe. Let me zoom into that one. Where did it go? Path explorer.exe. Name. Wait a second. Select. Okay, but that one looks good. We're processing. It's interesting though that it reports on explorer.exe. Let me rerun that one. Amazing, right? Yeah. Let me look into that query in just a second. But interesting result though. I would imagine it links to what I just did because because the parent process is actually Explorer, so that makes sense. But would I expect the query to actually return the SVC host as well? But still, this is an interesting result though. So let's go a step further. Let's, by the way, test if it's actually related to what I'm doing. If I do this, I think it should return no results. There you go. Yeah, so that one has no results. The other one does, it just returns the parent process name, which is obviously explorer.exe because I double-clicked the SVC host. You might want to then, of course, adapt this query a bit further to get some more visibility, right? So it's all about enriching, adding stuff, keeping it going. That's the whole idea. A couple of others. So this is another one where you create a join. This is another query that we've been playing around with. So now it's no results found because it's actually gone. That payload, it's actually a meterpreter. It tries to pull in another stage, but it's not working out because my payload is not working at the moment. So that's why it's gone now. Other example here is looking into machines which are setting up remote connectivity, looking at processes which are connecting outbound. So what does the query look like? So as you can see here, what am I doing? Select s.pyd, p.name, local address, remote address, local port. remote ports. So I'm trying to find systems which directly connect outbound. Let me just extend this one. And I'm putting remote addresses not in your typical local host or your local networks. I want to get rid of that. And then you can see some interesting visibility. You can see that I have a putty running, of course, which is connecting to one of my internal networks on 192.168.30.16. You could, of course, add your remote your local network ranges into your whitelist to not see those. So those are things that you can get up and running as well. But this allows you to, of course, see processes which are connecting outbound which shouldn't be. So those might be interesting ones to look into. So there we go. That's all just running standard queries. So let's start looking at some of these packs, right? So how do you develop a pack? Pretty straightforward. You could say, okay, let's start scheduling. A pack is basically a scheduled query, if you will. So let's say select services. And I could say, well, I want to create a new pack which runs on all of my Windows machines because I want to monitor a possible persistence strategy of adding a new malicious service, if you will. So I create a pack. So it's there. So now I want to add some queries. So you can see here that first let's add a query, and then you can start defining how and when it needs to run. But we need to add queries. I don't have any queries yet, so let's create a very basic one. Select start from services. Run. Right? Oh. There we go. Just testing it out to make sure it works. It's collecting a ton of information. It's a bit slowish. Because here, as I mentioned already, just while we're waiting for the query to run, all of the different tables that are available to you, what you can query, how you can do things. Let's just use another one for now. Yeah, this is a lab environment though, so my machines aren't ultra spec'd. Let's just do select start from processes to get the process list. I'll just add that one to a query pack. Uh-oh. So please close your eyes for a second so you don't see my password. I'm just going to have a very quick look at my OSQuery service. Just going to restart my service just to be sure. Okay, seems to be good. So it immediately starts responding again. Okay, that's good. Maybe I messed it up with the previous query, but I just restarted the service for a second. It does work quite well. Do note that this is a lab environment, so we sometimes have we do infect these machines with some junk as well. So they are sometimes a bit annoyed. As you can see, this guy here, you might recognize that one. That's a pretty ugly one. So let's carry on. So imagine I would use this one and I save this query, for example. I could say select processes. I'll call it this way, for example. Save this query. So it's a new query that I'm creating. There we go. So it's available there now. If I go to the packs, I could say select Windows services, but let's call it select Windows processes, for example, to periodically collect information from your Windows endpoints or any other endpoints as well, because you want to get information about the processes. So what kind of query would you want to add? Select processes. And this is where it gets interesting, because you can now say, okay, but how many times do you want to run it? What's the interval between that? You can define it in seconds. You can define on what platforms you want to run it. So I could say, for example, I want to run it on all platforms. I want to run it every hour. The minimum version of OSQuery that you need. And here's the interesting one, the differential logging, for example. Show only what's added from the last run, which is differentials. Snapshots will show you everything in the current state. So it's a bit more aggressive, if you will, snapshot. It's going to collect a lot more data, but it also allows you to better investigate, to baseline your environment. So for example, I can do a snapshot. Let me just put this one on every 20 seconds, for example. I want to collect data. This is a bit aggressive. It's a bit too much, but I just want to do it because that will give you some visibility, and we'll start seeing some results for me as well, because I'm of course going to be getting that into my Elastic Stack. So this is running now. So every 20 seconds, this should start collecting information. Let me just use my stack here, my Elastic Stack, to get some visibility. And I'm just looking at discovery. I haven't built the full dashboards yet. That would be your next step, but I'm just looking in the discovery to find information about OSQuery. So I'm just looking for OSQuery. So these are Windows event logs. Interesting. Very nice. This is probably why my application broke just before, because I broke it. So these are, of course, Windows event logs. They're not yet the results of your OSQuery queries which are running. So let me see. There we go. So here we can start seeing information that's coming in. So you can see that there's information coming in. You can see here that there's a snapshot information. It's all still in JSON. Now, the one thing that you would want to do, of course, is you can see here, for example, pack, select Windows process, select process. So it shows you the values, the information that it's taking, that it's getting. Now, of course, you can configure Elastic, because all of this is JSON, to get these in parsed fields as well, so to get more visibility. So let me scroll down here a bit, because this is just one raw event, as you can see. So that's the whole one. It tells you where it's storing it. And you can see here, of course, that they are at the moment yellow. They've got like a small warning sign. That's, of course, because they haven't been indexed yet, because these are new fields that I'm doing. Now, what's going to happen now, of course, is I'm going to start getting this information on a periodic basis. So literally every 15 seconds, well, I think I put 20 seconds, I'm going to start collecting this. And now the whole idea would be to, first of all, further parse this, to have the snapshot as JSON, to do the nested JSON parsing in Elastic. And then, of course, you could start getting visibility on top of it. It doesn't have to be Elastic, of course. You could also use an engine like Splunk or anything else. But the whole idea here is that you start developing periodic queries. Now, I want to make sure that we have sufficient time for questions and remarks. I'm just going to have a quick look at this guy. So let's have a look. Select Windows processes. Okay, that one seems to be running. It's running fine. Okay, that's good. So I think that's a bit about that's a bit the demo that I want to show, just to show you, okay, this is how you can configure things, how you can develop packs. The whole idea again here is how do you make this practical? How do you start using this? How do you make this tangible and actionable? Start looking into, okay, but how can you start doing detection? How can you start doing routine data collection? And what are some of the interesting queries that you want to be running? I just gave a few examples, but in the end, OSQuery is only limited to your imagination. There's so many different tables to choose from. There's so much data available that you can do a wide variety of different things. I do like a lot of these community-driven initiatives. There's others like, for example, Sigma. So Sigma doesn't really focus on OSQuery, but you can get some pretty interesting insights there as well on how to do proper detection and how to start doing that. Again, OSQuery is a very active project, so it's very actively being developed. The same for Kolide as well, with Kolide Fleet. So that's something that you can zoom in on as well. So I'm just opening my slides here again. So that was the demo, and I think we can probably open it up for Q&A as well. I'd be happy to answer to any of your questions or any of your remarks if you have any additional ideas or things that you want me to look into.
All right, Eric, thanks for that great presentation. We do have some questions ready for the Q&A. However, if anyone has a question for Eric, please enter into the questions window now. Our first question is, if you use the OSQuery to detect something, can the output be sent to the SIM to alert or track it?
Yes, so that's a very good question. What I did here was indeed I used just Elastic. So definitely. So all of the output of Kolide. So the whole idea in the architecture here is OSQuery is running on the endpoints, and it's forwarding everything to Kolide. So between OSQuery and Kolide, you just have TLS connectivity. Everything is logged at Kolide and it's stored in JSON format. So it's a very parsable format. I just showed you a quick one in Elastic. The whole idea would be indeed to configure it to get into your SIEM, and you can start looking into that. Definitely, that's exactly what you would be doing.
All right, thank you. Is there an agent on the machines that OSQuery queries, or how does it parse these machines?
Yes. So OSQuery uses its own agent, which is the OSQuery agent. For the standalone, it just runs standalone. But indeed, for the one that I showed you now, how it's installed, it's running as a service on Windows systems, and very similar setup as well for Linux-based environments. It does use an agent indeed.
All right, thanks. I just have some feedback. They say, amazing webcast, Eric. You've put huge efforts into developing OSQuery Lab for SEC 599. Well done.
Okay,
One more came in. Once a query is executed with all endpoints, will all endpoints execute it at the same time, or will it execute at different times?
So the thing is, the timing or the interval is scheduled centrally. So you configure it centrally. So that does indeed mean that they will just periodically all start running it at the same time. You could, of course, adapt it by changing the way you put your packs in different groups, and so to change the intervals there in Kolide. It's something you could do, but if you run it on all of the hosts with the same interval, it's going to run at the same times. But indeed, imagine, for example, where you have a resource limited environment or you have limited bandwidth available. There you could investigate going for a setup like that. That would definitely be something that you could do.
All right, thank you. What kind of permissions should the agent have?
The permissions, yeah. So the agent does run with local administrator privileges because, well, it has visibility on all of that. For example, even if you're running if you want to try to access the Windows event log, for example, the security events, you will need local admin rights. So it does run with local admin rights. What's important to note though is that because like EDR tools, for example, will have very similar requirements. But what's important is that OSQuery doesn't run commands. So if you are a bit concerned about, for example, the security implications of it, the only thing it can do is collect information. Unless, of course, there would be a vulnerability that gets identified and needs to be patched. But even if Kolide gets hijacked, if you will, the only thing it can do is get information. It doesn't have any capability to launch processes, kill processes. So in the end, it's limited to data collection, if you will.
Thank you. What's the resource utilization if you run a large collection of queries on the same host?
So what's the resource and resource utilization? It depends a little bit. If you're running standard stuff like the select start from processes, it's pretty fast, it's pretty quick. The one thing I would advise though is spreading that a bit and not overdoing it, because you're not trying to replicate real-time monitoring. If you're going to be selecting all of the processes every 10 seconds, you're kind of trying to replicate real-time monitoring with OSQuery, and that's not really what it's designed for. What I would advise is going for the data collection capability. For example, running a bunch of queries every week or every day even. And then the impact is going to be very limited because OSQuery only gets active when it starts doing all of that stuff. So that's a bit the approach probably there. Because if you are doing some of the more intensive queries, you might indeed get a bit of utilization, or it might have a bit of a CPU load. It is manageable though. I haven't seen too much issues with that. I've seen it as being a very performant agent. So I've seen some very good results with it. But of course, you always want to look after your production environment, test it first, see how you do things, because it all depends on the type of queries that you're creating.
All right, thank you. Can you kill queries once started?
Yes, so you have the stop button that you can use for the queries. That's one thing you could try doing, or worst case, you could just kill the service, but that's pretty aggressive. Do note that yeah, you want to monitor that. You want to have a look and you want to make sure that the queries, if you would write a very crazy query which is going to do a lot of different joins and it's going to collect a lot of data which are intensive, you might cause an impact. So you want to test first before you start pushing queries into your production environment.
Okay, this next one, I'm not sure if it's a question or a comment. He says, I guess it will require a pull request to get SHA-3 hashes too.
Yes. At the moment, it's not supported yet. You can actually check in the table section. So one of the tables is hash, and that one doesn't have it yet. So it just has SHA-256, SHA-1, MD5. That's the stuff that it has. So if you want anything else, then indeed that would need to be an adaptation that they make.
All right, thanks. This next question says, we have run some initial tests and found Graylog2 to be interesting when it comes to JSON filtering and enrichment of events. When using Elastic, do you have some storage figures we should foresee for Elastic when we start querying endpoints?
That's a very good question. So storage requirements. The nice thing I like about Elastic is that it's easy to cluster and to expand, but it all depends on the type of queries that you're looking for, that you're trying to achieve. Also depends on the retention a bit. So to actually have storage numbers, that's a bit of a tricky one. Now, if you do really have more questions, feel free to hit me up on Twitter on that specific one. If you have a bit more of information about your environment, or even drop me a quick mail, you can probably find my contact details, and I'd be happy to think about it. It's hard to just give you a baseline number just like that.
All right, thanks. Is there any protection mechanism for OSQuery service? How do I know if the service crashed or stopped?
Yeah. That would probably be something to pick up on your a couple of options. Kolide monitors it, so you will see in the Kolide interface which engines are up and running. So once the service goes down, you noticed it with me now, a bit unfortunate in my lab environment. Usually that doesn't happen because I did this demo 5 or 6 times and never really had an issue. Of course, it happens when I'm broadcasting live, but you will see it quite easily in the central interface. You will see that there's a red one. Otherwise, you can just use. You probably have some kind of monitoring capability as well you're using to see if your systems are running as they should be. So that would be an option as well to do. But Kolide will also tell you. It will tell you, oh, you've got 20,000 hosts, for example, but I only see 19,900 online now. So you will see the ones which are in red. So you can investigate why the service is not running on those machines. So you will see it. Yeah.
All right, thank you. Is there an initiative to audit all the query packs that are shared in open source?
Oh, good question. So an audit, if there's really already an initiative to start doing that, I haven't seen it just yet. So that's not something I have seen. So that's definitely something you want to look into yourself. I share a lot of these as information, as good creative ideas, but you definitely want to look into them. Because to be fair, and I love the open source community, I love people who are contributing stuff. Not all of us are the best SQL writers, so some queries will be effective, but they might not be the how would I say, the most the most performant ones. So it depends on how they are written. So you do want to look at that yourself before you deploy them in production. There's currently no community-wide initiative to audit the stuff that's online, that's out there, at least not to my knowledge.
Okay, thank you. Did you review Kolide against Zentral?
No, sorry, I haven't. So that's not something I have done.
All right, thanks. And our last one for today, does Kolide have a CLI environment or CLI?
Yeah, so a command line environment. So Kolide, as far as I know, doesn't have it because, well, the whole idea is that they make it enterprise-wide. Now, OSQuery itself does have command line interface that you can use. Now, not interactive, but if you are on the system, you can actually use OSQuery I, which is an interactive OSQuery shell, which allows you to run queries ad hoc on the endpoint. Now, Kolide, as far as I know, they don't have that just yet. So they don't have any, and they don't have it yet, to my knowledge.
All right, well, that's all we have for today. Thank you so much, Eric, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.